Hi everyone, I hope you're okay. This is video number 10, guys, the last video of me tackling the question paper of 2022 November examination. It's maths paper 1, yeah? Yeah, let's just get right into it, guys. A, B, and C are three events. The probabilities of these events or any combinations of them occurring is given in the Venn diagram below. Okay, we are told that if it is given that the probability that at least one of the events will occur is 0.893, which simply means that the difference between 1 and 0.893 will be y. Why am I saying that? Because 0.893 just covers the three events, the sum of all the probabilities in here are together. But remember that under a sample space, the probability must always sum up to 1. So it simply means that 0.893 plus y must give us 1. Therefore, 1, the value of y is 1 minus 0.893. This will give us 0.107. So the value of y is just 0.107. Are you together? And then secondly, they want us to find the value of x. I know that the probabilities over there, they all sum up to 0.0893, right? So I'll simply say 0.05 plus 0.15 plus 0.05 again plus 0.2 plus 0.183 plus 0.1 plus x must give me 0.893. So therefore I'll simply have 0.05 plus 0.15 plus 0.05 plus 0.2 plus 0.183 plus 0.1. I will have x plus 0.738, or it's 733. This is equal to 0.893. So therefore x is equal to 0.893 0.893 minus 0.733. This will give me 0.16 as the value of x. So x is 0.16 and then y was 0.107. Okay, now I'm supposed to determine the probability of at least two events occurring. At least two events occurring, I will simply look at the combinations only. Are you together? So I'll take this probability plus this one, and that one. Are you together? So the probability of at least two events occurring, I'll take 0.15 and x, that's 0.16, and then 0.12 plus 0.1. This will give me 0.15 plus 0.16 plus 0.2 plus 0.1. This will give me 0.61. Are you together? The probability of at least two events occurring, that's 0.61. Okay, are events B and C independent? Justify your answer by means of calculations. Where is B and C? Okay, these two events will be independent if and only if the probability of B multiplied by the probability of C is equal to the probability of B and C. Are you together? I can simplify the probability of of B, the probability of B, I'll simply add all of these things. It's 0.1 plus 0.183 plus 0.2 and x, which is 0.16. The probability of B, 0.1 plus 0.183 plus 0.2 plus 0.16. Probability of B is simply 0.643, né? And then let me find the probability of C now. The probability of C, 0.05 plus 0.2, 0.16 plus 0.15. 0.05 plus 0.2, 0.16 plus 0.15. I'll simply get 0.56. And then for the intersection, the probability of A and B, this is the not A and B rather, but B and C, né? Is B and C. This is the intersection they're talking about. So that's 0.2 and 0.6, 0.2 plus 0.16, which is just 0.36. So if these two multiplied is equal to 0.36, then the two events will be independent. So let me check. Probability of B multiplied by the probability of C, I'll have 0.643 multiplied by 0.56. 0.643 multiplied by 0.56. This will give me 0.36008. This can be rounded off to 0.36. 0.36. It can be rounded off to 0.36. So therefore I can conclude that the probability of B is B and C are independent. Why am I saying that? Because the probability of B times the one of C is equal to the probability of B and C. Okay, now I'm told that a 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated. Okay, it's a 4-digit code, né? Like this. And since it's a digit code, how many digits do I have? I have 0 to 9. In total, that means I have 10 digits altogether. But in my 4-digit code, I must not use digits 0 and 1. So this simply means that I will only need digits from 2 until 9. So the number of digits that I will be using, I'll be only using 8 digits. Are you together? Okay. And the digits may not be repeated, né? Question number 1. How many possible 4-digit combinations are there? Okay. Did they say that the digit must be even numbered? Let me erase here. A 4-digit code is required to open a combination lock. The code must be even numbered, okay, and may not contain 0 or 1. So since the code is even numbered, né, it simply means that it must be divisible by 2. Excuse me, it must be divisible by 2. And for any number to be divisible by 2, the number at the end, rather for any number to be an even number, the number which is at the end should be the one which is divisible by 2. Are you together? So since I'm not supposed to use 0, I'm not supposed to use 0 and 1, That means the numbers that will be in this placeholder, I'll only have 2, 4, 6, or 8. These are the possible 4 numbers that will be there in that placeholder. Are you together? So this thing simply means that the numbers that will be here are dependent on this one. Are you together? They are dependent on that number. So in general, there are 4 options to choose from in here. Are you together? There are 4 options to choose from, and then after I've chosen one number from here, that means in the first digits I'll be left with 7 numbers to choose from. So I'll have 7 numbers to choose from, and then since I've already occupied 2 spaces, that means I've eliminated 2 numbers from the total of 8 numbers. That means in this placeholder I'll simply have 6 numbers remaining to choose from. So I'll write a 6 there, and then since I have total of 8 numbers, 8 digits to choose from, I've already used 3 of them. That means I'm left with 5 to choose from. Are you together? Which simply means in this placeholder I will simply have 5 numbers to choose from. So these numbers over here, they will represent the possible outcomes if they are multiplied together like that. So I'll simply have 7 times 6 times 5 times 4. And this will give me 840 possible combinations. 7 times 5, 7 times 6 times 5 times 4, 840 possible combinations. Are we together? Okay, now we are supposed to calculate the probability that you will open the lock at the first attempt if it is given that the probability, or if it is given that rather the code is greater than 5,000, number 1, and the third digit is 2. So I already know that here there's only one number in this placeholder, and that number can be 2. I don't care what happens on the other placeholders. Né? Okay, since I have a 2 there, né, I know that my code has to be an even number. Are you together? So that means the number at the end can be 4, or it can be 6, or it can be 8. I cannot choose 2 because 2 has is in the third digit placeholder. Are you together? Okay, so in this case, guys, since my digit code has to be greater than 5,000, it simply means that the number that is here, it has to be 5 or any number which is more than 5, right? So then the numbers that get to be in the first placeholder are 5, 6, 7, 8, and 9. Are you together? And then here I can have any number. Are you together? Okay, so now let's start. Let's say we have an odd number in the first placeholder, an odd number such that we start with either a 5, a 7, or a 9. Are you together? It simply means that we have 3 numbers to choose from in here. Né? Let me use a different color. I will have 3 numbers to choose from on the first placeholder, and I'll also have 3 numbers to choose from on the last placeholder. I know that here I'll only have one number to place here, and that's 2. Remember that I had 8 numbers. I have already used 3 of them. That means I'm left with 5 numbers. That means I have 5 numbers to choose from. Are you together? So if the first placeholder is an odd number, these are the possible outcomes that I will get if the first placeholder is an odd number. Are we together? So this will give me 3 times 5 times 1 times 3. This will give me 45. Are we together? So if my first number is an odd number, it simply means that the possible outcome that I have is just 3 times 5 times 1 times 3, ne? That will give me 45 plus, remember that I can have two options. The placeholder here, I can start with even numbers, 8 and 6. 8 and 6 can be the only number, can be the only even numbers that can start here. Why? Because there was a stipulation that the code must be greater than 5,000. So the numbers which must be here, they must be greater than 5, ne? Those even numbers must be greater than 5. Okay, so I have two numbers to choose from in here, guys. Are we together? That's why I'll say 2. And then in this placeholder, I know I will have a 2 there. Are we together? But in here, if I use an 8 first, that means I must cancel an 8 and I'll only left with the 4 and the 6 to choose from. Are you together? Or if I choose a 6, I must cancel the 6 and then I'll be only left with 4 and 8 to choose from. Are you together? So now it changes. If I start with an even number, that means I will have 2 even numbers left to be placed in this last placeholder. Are you together? I know that I had 8 digits to choose from. I've only used 3 of them. That means I have 5 left to occupy this position. One of them will occupy that position. Are you together? And this will be a possible outcome if I multiply this. That's 2 times 5 times 1 times 2. Are you together? All over. Okay, before I do that, I know that this thing will give me, this is 45 as I calculated earlier. This is 2 times 5 is 10 times 2 is 20. So this will give me 65. Are you together? So these are the possible outcomes that I will have if I obey these stipulations. Are you together? So these are the possible outcomes. Therefore, my probability, obviously, probability is equal to the number of desired outcomes all over the possible outcomes, right? I'll simply have 65 all over 840. 65 divided by 840. This will give me 0.07774, or I can write it into 2 decimal places if I want to. 0.08. That will be the probability, guys. Whew. Just stay tuned, guys, and wait for more videos. I think I'll be uploading the IEP examination and paper 2 as well for this exam. Just stay tuned, guys, and wait for more videos. Please don't forget to subscribe, like, and share the videos. Thank you very much.